Hi, I'm Anand Chaudhary, an 8th grader from John F. Kennedy Middle School. And recently we've been talking about limits in our whole calculus series. We've been discussing about limits because they're probably one of the most fundamental things to know in calculus. And so today we're going to advance on from that, and we're going to go on to a subsection of limits called one-sided limits. Now, one-sided limits are used when both sides of your limits just don't match up. And people do have that problem where when they're trying to calculate the limit from the left side, it's different than what comes out from the right side. So in this video, we're going to discuss about what you can do for, you're going to learn what to do for one-sided limits and what happens when they don't meet up. So why don't we head on into it? At first, we can see we have a graph here. I labeled it fx, a very standard function name. And we can see that we have two kind of curves which are from the same function, and they have a break at x equals 2. So we're going to use that, and obviously seeing here, this is like where one of the main problems happens, is when from the left side, the limit is different than from the right side. Because see, as we are approaching 2 from the left side, what happens is that it is equal to -1, and from the right side it's equal to 1. So they're not quite equal. But what are we going to do about this? Well, honestly, we can't do much. But our main priority is by, first of all, splitting up the one-sided limits whole subsection into the two different sides. The right-sided limits and the left-sided limits. The two very basic standard splitting of limits. So the first thing we're going to do is discuss about right-sided limits. Now, let's just get our facts straight about what side is right side, what side is left side. This is the right side on this side of the board. This side is the left side. So if I were to ask you which one of these is right side and which one is left side, this is going to be option 1. This is option 2. Which one is right side? It is the first one. This option 1 here is the right-sided limit, and not the right-sided limit, the right side part of the function that we're going to use to find the right-sided limit. Now, before anything, I'm also going to use a table to show you guys how these one-sided limits work. Okay, so our goal in this video is to find out the limit from the right side and left side as x is approaching 2. So let's say these are our x's and these are our y's, or yeah, let's keep it like that for now. We're going to have our value of 2 right over here. So let's keep the left side away from us for now. And we're going to have our right side available because we're going to talk about right-sided limits first. So let's start off with basically, how do you write right-sided limits? Like, we know that you write limits just like LIM as x approaches to 2, f of x is equal to whatever. But we're not trying to do that. We're trying to find out from the right side. So in order to do from the right side, very simple, you're just going to add a little subscript at some certain point. So we're going to have our basic lim as x approaches to 2 of f of x is equal to, we don't know yet. But what to do in order to make it the limit of a right side, or how to make it a right-sided limit, is you're going to add a little subscript over the 2 of an addition sign. Obviously meaning for the positive side of the graph. The positive side is the right. So that is how you write a right-sided limit down. Now, as we've been discussing, finding a limit basically means what value it's approaching from the right side in this case. So from the right side, not looking at the left side, if we think of numbers from the right side, we would think of 3, 4, 5, 6. But in order to find a limit, we've got to think of minutely close numbers to 2. Okay, so over here we can have, let's say, 2.01, 2.02, 2.03. All very close to 2. Okay, now I'm not going to go into how to find these exact values, but if we were to take a very close look, we can see that all these numbers, 2.01, 2.02, 2.03, seem to be approaching the value of 1 as our function is going. Like, we could just see it through our function. It is definitely approaching the y value of 1. So it's already giving us an idea of what this is equal to. But as we can see, there's a break in the function, and from the left side and right side, they're not quite matching up. So basically, from what we have here, we are finding out that the right-sided limit is approximately equal to 1. So I hope this did help you a little bit, because I'm just using the table to help explain to you what type of numbers you should be using in order to find limits. It's no problem if you're having a bunch of numbers and you're trying to find, let's say you have a much bigger number and you use a whole 1 unit difference between the numbers. I think that would be completely fine, but just for this example here, I'm using minutely small numbers. Now we're going to erase that right side and we're going to go on to the left side in just about a second. But as we just saw, from our right side, we did get an approximation of 1. So the limit as x approaches to 2 from the right side of f of x equals. Now, one thing I should probably mention, I don't like how in the equation they say equals. I think they should be saying an arrow just like they do here for approaches to. But I guess that's just how mathematicians decided they would be, because it's already such a standard in math, the equal sign. So we're going to write is equal to 1. So as I explained the right-sided limit, the left-sided limit is almost exactly the same. In which basically you're just going to find the limit of the left side. Now before heading on into this, we're going to find left side numbers. So basically from the left side of 2, if you were to think about it, 2, 1, 0, negative 1. But we're going to, again, because our example is very small, we're going to use minutely small numbers again. So we're going to use 1.99, 1.98. So basically meaning over here somewhere, right next to the 2. And if we were to take a look at where these numbers are heading towards, since they're very close to 2, probably right around there-ish, we could see it's heading towards negative 1. So basically kind of the opposite of positive 1, it's heading to negative 1. So that is basically how you would kind of use a table for limits. And I hope it kind of helped you just a little bit. But now we're going to go on to how to write left-sided limits. Now, like right-sided limits, you write it basically the same as a normal limit, except you add a little subscript. So basically, we would write limit as x approaches to 2, because that's what we're trying to find here, of f of x is equal to, and we already know it's going to be negative 1, but we'll hold on to that for just a sec. In order for it to be left-sided limit, you have to write a negative sign subscript. Now, the way I like to think about it is this. The reason we have right-sided limits with a positive subscript is because of the fact that it's on the positive side of the graph. The positive side is on the right side. And the plus sign is basically referring to positive side. Left-sided limit is the complete opposite. It's referring to the negative side of the graph. Though it may not be in the negative side of the graph, it's more towards the negative side of the graph. So that's how I like to think about it. You guys may have your own ways of thinking about your right-sided, left-sided limit subscripts, but that's just the way I like to think about it. And as we know, for this example, the limit of as x approaches to 2 of f of x is negative 1 in this case. Because as you can see over here, left-sided limit, we just label these here, left-sided limit, right-sided limit, just so everyone's clear here. And so this one is equal to negative 1 because it's approaching the y equals negative 1, and this one's approaching 1. So that's basically, very simply said, one-sided limits split into right-sided and left-sided limits. I hope this video did help you a lot. Hope it helped you get through your section on one-sided limits. Please subscribe to the channel and like the video. Please leave feedback on these videos. I would definitely read them. Thank you for watching.